Good morning, students. In the last class, we discussed the special type of semiconductor. That one is the Zener diode. So today we will discuss few more types of semiconductor devices. That is semiconductor devices. That one is opto electronic junction devices. So what are optoelectronic junction devices, right? So optoelectronic junction devices means these are the devices which uses both the technologies of optics and electronics, right? So what are optoelectronic devices? So these are the devices which uses or which works under both the technologies. So which works under both the technologies, that is optics and electronics. So in optoelectronic devices, right? So the charge carriers are generated by photons. So as we already know, photons is nothing but the energy packets. So right, so photon is nothing but the energy. So that one has the energy packets E is equals to h nu, right? So this is about the optoelectronic junction devices. So what are optoelectronic junction devices? So these are the devices which works under both the technologies of optics and electronics, right? So here the important is optics and the electronics. It uses both the technologies, right? So next, in optoelectronic junction devices, right? So the charge carriers which are present in the semiconductors, that is produced by the photons. So photons is nothing but the energy packets, right? So this energy packets, we have the energy E is equals to h nu, or E is equals to hc by lambda, right? So in our syllabus, we are discussing about few optoelectronic devices or optoelectronic junction devices. So in that, first one is light emitting diode. So the first one is light emitting diode. So this one we call as LED, right? So the next second one is photodiode, and third one is solar cells. So these three we call as optoelectronic junction devices, or we call these three as optoelectronic devices, right? So the first one is light emitting diode, and the second one is photodiode, and third one is solar cell. So now we will discuss one by one. So starts with light emitting diode. So what are light emitting diode? Right. So the first one is light emitting diode, or we calling this one simply, that is LED. Right. So these are the PN junction diodes, that is highly polished PN junction diode. So it works under forward bias. Right. So these are the, what are light emitting diodes? So light emitting diodes are the highly polished PN junction diodes and works under forward biased condition, right? So what are LEDs? So LEDs are the highly polished PN junction diodes. so it works only under the forward biased condition, right? Then it emits light. So this one is the special feature of the light emitting diode. That means it emits light. So what are PN, that is what are LEDs? So LEDs are the highly polished PN junction diode and it works under the forward biased condition and also it emits the light, right? So next, principle. So principle of the LED, right? So as we already said, it is highly polished PN junction diode. So first we need to write the PN junction diode, right? So this one is the P region and here it is the N region. So as this PN junction is works under the forward bias, then P is connected to the positive terminal of the battery and N is connected to the negative terminal of the battery. That means P is positive and N is negative, right? Now, as already said, so this one is the junction. As this highly polished PN junction is works under the forward bias, that is, we are connected the battery, that one positive terminal of the battery is connected to P region and the negative terminal is connected to the N region. So here the electrons which are present in the N region is moving towards the P region, right? So that means the electrons are diffusers from N region to the P region, right? So in P region we have positively charged. That means here holes are present in the P region, right? So these are we call as holes, and in N region we have electrons, that is negatively charged particles. So as the electrons move from N region to the P region, it combines with the holes, right? So during this process, the energy is transforming from higher energy state to the lower energy state, right? So as it jumps from higher energy state, so this one is the high energy state. So here is the lower energy state. So as it transforms from higher energy to lower energy state, so due to this difference in energy levels, so it emits the radiations, that is in the form of photons, right? So in the junction it emits the radiation, right? So this one we have called the energy E, right? So the principle of working of LED is, so as we say LED is working under the forward bias, for that reason P is connected to positive terminal of the battery and N region is connected to the negative terminal of the battery, right? So as the electron which are diffusers from N region to the P region, and in the P region we have the holes, right? So these holes we call as acceptors, because it has electron deficiency, right? So as the electron which are moving from N region to the P region, so it combines with the holes, right? So because here there is an electron deficiency, as this electron moves to the P region, it forms the electron hole pair, that means hole electron pair, right? So during this process, the energy of the electron is transferred from higher state to the lower state, right? So as we discussed in the chapter atoms, as the electron which is transforming from higher state to the lower state, it emits the radiation. That means that atom releases the energy when it jumps from higher energy state to lower energy state. So that means when electron is paired with the hole, so during that process the electron is jumps from higher energy state to lower energy state. So during this process the energy will be released in the form of the radiation. So that radiation is having the energy E, that is equals to H2, or that energy we have Hc divided by lambda, right? Where lambda is the radiation of the emitted wavelength, right? So for that, if we return the relation, That is lambda is equals to Hc divided by Eg, where Eg is the energy gap between the two energy levels, that is between the conduction band and to the valence band, right? So here where H is Planck's constant and C is speed of light and Eg is the energy gap, right? So this one is the wavelength which is emitted during the forward biased condition. That one is the light, right? So here one more important point is silicon, right? As silicon is commonly used semiconductor diode, so as this silicon is connected with the positive, that means forward biased condition, so this silicon will not emit light, right? So as we said, LED will emits the light, right? So silicon is a semiconductor. So this semiconductor, if we forward bias means it will not emit any light. The reason because here in silicon it emits the frequency, that is it emits the radiation having the lambda, right? So its wavelength will be in UV region. So in this region, the radiations will not be visible. So for that purpose, it will not any emit light, because the radiations having the wavelength which will be in the UV region. So in that region, it not visible to our eyes. So for that reason, silicon will not emit any light. That means silicon semiconductor, that is silicon LED will not emit any light, because the emitted radiations having the wavelength which falls in the region, that is in UV region. So in this region we are not able to see the wavelength, so for that reason it will not emit any light, right? So next is VI characteristics. As LED is forward biased, right? So the VI characteristics is IV. So here current is in microamperes and V is the applied voltage here, right? So as we increases the voltage, so it slightly gives, that one is the current, right? So this one is the VI characteristics of LED, right? So next, applications of LED. So where we are going to use these LEDs, right? So the first application is it is used in remote for TV, right? So it is used in TV remotes. Next, it is used in optical fiber communication. It is used in optical fiber communication. So next one is it is used in, or it is used as displays in watches and calculators, right? So these are the few applications of the LED, right? So if they ask for 1 marks or 2 marks, we need to mention, right? So what is LED? So LED is a highly polished semiconductor diode. So it emits the light. So it works under the forward biased condition. Next, the principle of LED is, as the LED is connected to the external voltage, that is P type is connected to positive terminal and N type is connected to the negative terminal, the electrons which are present in the N region will move to the P region, right? Because these are the donors right? So as we discussed in the N-type semiconductor and P-type semiconductor, as the electrons which are diffuses from N region to P region and combines with the holes. So as holes are the acceptor, so during this process the electrons will shift from higher energy state to lower energy state. So during this process it emits the radiation of the energy E. So that one is given by E is equals to Hc divided by lambda, or we know the lambda, we need lambda because it emits the radiation lambda. So lambda can be written as lambda is equals to Hc divided by Eg, right? So it is works under the forward bias condition. Then IV characteristics is similar to that of the semiconductor because it is also the semiconductor devices, right? So forward characteristics taking voltage along x-axis and current along y-axis, we get the similar graph, that is semiconductor diode when connected in forward biased condition. So next is applications of LED, right? So it is used in the remote for TV and it is used in optical fiber communication. That means it sends users in sending the signals. So in there only uses the LED. Next, it is used as a display, right? So displays or display in watches and in calculators, right? So these are the applications of LED. Next is advantages of next advantages of LED, right? So those are the applications. So these are the advantages of LED over incandescent, right? So the first application is it uses less voltage. It is first advantage over incandescent, right? So the second one is the power loss is less. Next, it takes less time to emit radiations or light. It takes less time to emit light. So it has long life, right? So these are the advantages over the incandescent. So that means incandescent bulbs as we use in our homes, right? So over that one we use as the LED. So this LED has the few advantages, that is it requires only the less voltage. For only less voltage we get the light, right? So the second is the power loss is less. Next, it takes less time to emit light, right? So it has a long life, right? So these are the advantages of LED over the incandescent, right? So the symbol, circuit symbol of LED, that is it is a PN junction diode, right? So similar, here it is P and here it is N. So along with this we need to mention the radiations, that is outwards. So it represents what? The circuit symbol of LED, right? So this one is important for 3 marks. So either they may ask for the principle, or they may ask for the applications, or they ask for the circuit symbol for 1 mark, right? Or if they ask for the lambda, that is emitted wavelength in LEDs, right? So this is about the LED, right? So what are LEDs? LEDs are the PN junction, highly polished PN junction diodes. So it is works under the forward biased condition and it emits the light, right? So the next one is principle. When the PN junction diode is connected to the external battery, so as it is forward biased, p-type region is connected to the positive terminal and n-type region is connected to the negative terminal. The electrons which are present in n region will move towards the p region and combines with the holes. So during this process, the electron, that is energy level, shift from higher energy to the lower energy level. So due to this difference in the energy level, it emits the radiation of wavelength lambda, right? So that energy we call as photon, right? So it emits the photon of energy hc divided by lambda, and lambda is the wavelength of the emitted radiation, right? So next is IV characteristics. It is similar to that of the IV characteristics of the forward biased PN junction diode, right? Next is applications and advantages. So this is about the LED, right? So next, photodiode. So next one is photodiode. So the second one is photodiode. So it is also a PN junction diode. It works under, it is a PN junction diode. It works under reverse biased condition. So it works under the reverse biased condition, right? So this is also the PN junction diode. It works under reverse biased condition. So next is principle of the photodiode, or we say this one as working of the photodiode, right? So as PN junction, it is a PN junction. So first we will write PN junction. This one is the P region and this one is the N region, right? Now it is a photo. Photo is nothing but light, right? So when a light of energy which is greater than the energy gap which falls onto the junction, right? So when the energy, that is light energy, which falls onto the junction, so this one is the junction, right? So this energy of the incident light which is greater than the energy gap, right? So energy of the incident light is greater than the energy gap, then here electron and hole pairs are formed, right? So the first point is when light energy greater than energy gap, incident on the PN junction, right? So first, when a light energy which falls onto the junction having the energy which is greater than the energy gap, so next what happens? Electron hole pairs are formed, right? So here in the P region we have minus, so in the N region, so here we have plus, right? So now these two, electron and holes, that is negatively charged and positively charged, due to this electric field is formed, that is from positive charge to the negative charge, right? So due to this electric field, this electron will move towards the n region, and the holes are, that is positive charges, are move towards the p region, right? So here what happens, the electrons which are flow from negative, that one is the p region, right? So in this region we have the electrons, and positive charges which are in the region of the n region, right? So if you observe here, this one is the junction. So here we have the electrons. So here we have plus, right? So when a light of wavelength lambda which falls onto the junction, so due to this the electric field is formed, that means the electron hole pairs are formed. So due to this the electric field is produced. So due to this electric field, so this electron will move towards the n region, right? So electrons move towards n region, and holes move towards p region, right? So here if you observe here we get positive, after these are shifting towards p region. So here we have p region, right? So here it gets positive charge, and here we have n region. So here it is negatively charged, right? So when after this, that means the electrons are moved towards the, that is electrons which are present in this region move towards the n type, and positive charges are moved towards the minus type. So when the external resistance is connected across this semiconductor, right? So this one is the resistor. So here we have the current microamperes, right? So this one is the external resistance. So here the current will flow across the resistor. So that we call as photo current, right? So this photo current we will obtain the load across this resistance. So here we get the voltage V. So if we call this one as load resistance, we say this one as VL. We can extract the voltage across the resistance which is connected external to the PN junction diode, right? So this is about the principle of the photodiode, right? So what happens in photodiode means, when PN junction is subjected to the external light, that is when a light having the energy which is greater than the energy gap which falls onto the junction. So during this the electron hole pairs are formed, right? So due to that electron hole pairs are formed, the electric field is formed from positive charge to negative charge. Due to this electric field, the electrons will move towards the n region, and the positive charges will move towards the p region. That means here it completely become positive charge, and here it completely become negative charge, right? So due to this, when an external resistance is connected across this junction, that is across this diode, so we get the current flowing in the external circuit, and we get to obtain the voltage across this resistance. The current which is flowing in the external circuit, we call that current as photo current, right? So if the intensity of the incident light is more, then the photo current will also increases, right? So if the intensity of the light is more, then photocurrent also increases, right? So if we draw the characteristics, that is IV characteristics, it is works under the reverse bias condition. So hence the IV characteristics will come in third quadrant, right? So V taking along x-axis and current I in y-axis, that is negative y-axis, right? So it is measured in microammeter. So microamperes, right? So initially this current we call as black current. So this one is the reverse biased PN junction characteristics, right? So now this one is for the intensity 1 or I1. This one is for the intensity 2. That means if we increase the intensity of the incident light, then automatically we obtain the current more, right? So if you observe here, for the second intensity we have maximum current compared to that of the first intensity. If the intensity of the incident light is more, then automatically the photocurrent is more. So if the photocurrent is more, then the voltage we obtain across the load resistance will also more. That means, as we know, V is equals to IR. So this I is the photocurrent. If I is more, then VL will be more, right? So this is about the photodiode, right? So the circuit symbol for photodiode is, it is also the PN junction, right? So it will be like this. So here it is P and here it is N. So it works on the basis of the incident light. So the arrow mark will towards the diode like this. So this one is the circuit symbol for the photodiode, right? So next, the applications of photodiode. So where we are going to use this photodiode. So the first application, this is also used in optical fiber communication system. Next, it is used in switching circuits. It is used in switching circuits. Next, it is used to detect the visible and non-visible radiations. Or simply we say it is used to detect. So this is the principle of photodiode, right? So next one is circuit symbol of the photodiode. It is opposite to that of the LED. So in the LED, the radiations are emitted, but in photodiode, the radiations which falls onto the PN junction diode, right? So this one is the IV characteristics or VI characteristics. So as photodiode works under the reverse biased condition, right? So the graph will be in the third quadrant. So voltage along negative x-axis and current along negative y-axis. So as the intensity of the incident light increases, then automatically the current in the external circuit also increases, right? So this is about the photodiode. So this one is also, this optoelectronic junction diodes are important for 3 marks, right? Next one is solar cell. electronic junction device is the solar cell, right? So it is also a PN junction diode. So it is a PN junction diode, and it works under reverse bias condition. So this will be works under the reverse bias condition. So this one is similar to that of the photodiode, right? So here one difference is in photodiode we are obtaining the voltage. So in solar cell EMF is generated, right? So this is the difference between the photodiode and the solar cell. So in solar cell we are obtaining the voltage. So here in solar cell the EMF, that is electromotive force, is generated, right? So this one is in the separate chapter. We will discuss EMF, what is EMF and how they are obtained, right? So in solar cell EMF is generated, right? So this one is the difference between the solar cell and photodiode, right? So as this solar cell is also the PN junction diode, right? So here we have P region and here we have N region and we have the junction, right? So solar cell, similar, as I said, it is similar to that of the photodiode, right? So when a light of suitable energy which incident on the junction, right? So this energy is greater than the energy gap Eg, right? So next what happens? The electron holes pair or formed, that is hole electron pair or formed across the, that is along the junction, right? These are the minus and here we have plus. Next what happens? So due to this electron hole pair, the electric field is formed or electric field is produced, that is from positive charge to the negative charge. Next what happens? As the electrons will diffuse, that is electrons will move towards the N region and holes are move towards the P region, right? So from that, so this one is P region, here is N region, right? So here the hole which are move towards the P region and electrons are move towards N region, right? So then if you observe here, so this complete region becomes positively charged and this completely region is negative, right? So due to this junction, here we are obtaining the voltage, right? Across this junction we have already the voltage, we call that voltage is the breakdown voltage, right? So but that voltage is obtained from the external voltage we applied, but here we are getting the voltage across positive and negative charges, that is due to the light, that is solar radiation. Due to the solar radiation we are obtaining the voltage here, right? So here it is plus and here it is minus. So this voltage we call as photo voltage, right? So now in the same way, if we across this diode, if we connected a resistance, so here microammeter, so here we have the resistance, right? So the current which is flow across is IL or IC, right? That is photo current which is flowing across this resistance. So here we are obtaining the EMF, right? So that means we are obtaining the power. So power, that is I square, or here we call that one resistance is the load resistance. So in photodiode we are obtaining the voltage, that is IRL, right? So this is in photodiode, right? So this one we obtaining the power. That one is the EMF across this resistance. So that resistance is the load resistance RL, right? So this is the principle of the solar cell. So this one is almost similar to that of the photodiode. When a solar radiation having the energy which is greater than the energy gap, electron hole pairs are formed. So due to this, electric field is formed from positive charge to the negative charge. Due to this electric field, electrons will move towards the N region and holes are moved towards the P region. So due to those interchanging of the electrons and holes, so here we are obtaining the voltage. So that voltage we call as photo voltage, right? So when an external resistance is connected across this diode, the current will flow across this resistance. So from that resistance we are obtaining the EMF having the power that is equals to I square RL, right? So this one is the principle of the solar cell, right? So the VI characteristics, so VI characteristic of the solar cell, right? So here taking I along y-axis, so this one is in the fourth quadrant, V along in the positive x-axis. So current is in micro amperes. So here we are obtaining the voltage. So that voltage we call VOC, and here we are obtaining the current ISE, right? So the curve will be like this. So what are VOC and ISE? So VOC is the open circuit voltage and VIC is the short circuit current, right? So this is about the solar cell. So what is solar cell? It is a PN junction diode. It is works under the reverse bias condition and EMF is generated in the solar cell, right? So then next is principle. When a solar radiation having the energy which is greater than the energy gap which falls onto the junction, electron hole pairs are formed and electric field is produced from positive charge to the negative charge, right? So due to this, the P region is completely positive charged and N region is completely negative charged, and the voltage is produced, that is voltage across this junction is produced. So that voltage we call as photo voltage, right? So when an external resistance is connected across this solar cell, so calling this one as a solar cell, then the current is flowing in the external circuit. From that we obtaining the power, right? So that one is I square RL, right? So VI characteristics we get. So this VI characteristics which will be drawn in the fourth quadrant, right? So here there is a short circuit current. That means the resistance is connected directly from P to N. So that one we call as short circuit resistance, right? So the current flowing is ISC and the voltage obtained in that current, that one is the VOC, right? So here the voltage we obtained across this junction we call as photo voltage and the current we call as photo current, right? So this is about the solar cell. So next one is the applications of the solar cell. So this solar cell we use to supply power to electronic device in artificial satellites. So these solar cells are used to supply power to the electronic devices which are present in the artificial satellites, right? So next one is it is used to supply power to the calculators, right? So, and another one is it is used to supply power to the houses, right? So these are the few applications of the solar cell. So if they ask for 3 marks to write the application of solar cell, we need to write the 3 points, right? So this is about the solar cell, right? So this is about the topic optoelectronic junction devices. So what are optoelectronic junction devices? These are the PN junction diodes which works under, that is by using both the technologies. One is optics and another one is the electronics, right? So in optoelectronic devices, the electrons and holes, that is charge carriers, are generated by the photons, right? So that one we call as the energy radiation. So this one we call as photons, right? So by using these photons, the charge carriers are generated. So the main, in this chapter we have 3 optoelectronic devices, that is LED, light emitting diode, next photodiode and solar cell. So photodiode and solar cell both are working under reverse biased condition, both having the similar characteristics, that is similar principle of working, and in LED, that is light emitting diode, it works under the forward biased condition, right? So this is about the optoelectronic devices. So one more last topic in this chapter is electronic circuit. So that will be continued in our next class. Thank you. Any doubts?